Hello, welcome back to Dubeke Consult, and today we shall be having another series on column detailing. While we understand that the aim of every column detailing is to represent the reinforcement that will be used in the construction of these columns by lines and callouts. These lines and callouts needs to be represented in such a way that your artisans on site can easily understand and implement. In order to meet up with that demand, today we shall be introducing you to a template that can help you modify your drawing from your design software. It could be from Prota Structure, it could be from Orion, it could be from Start Pro. So this template will help you modify your structural detailing in order to meet up with the current industry standard. If you find this video helpful at any point, do not forget to like it and subscribe to our channel. And if you intend to get this template, I will leave a link in the description so you can get it from our online store. Hello, welcome back to Dubeke Consult, and today we shall be looking at column detailing with template. So I'll start off with this popular saying that goes, nothing is new under the sun, right? Because come to think of it, if we are to have the pyramids of Egypt existing in this modern civilization, so that's to tell you that the 7-story residential structure you are trying to design or you are trying to detail has actually been encountered, or something similar has actually been encountered by other structural engineers, right? So this is not to undermine your efforts. Yes, we understand that the structure you are working on is actually unique and is actually different from every other existing structure. But the truth is, your structural members or the properties of your structural members can be the same or relatable to previously designed projects. Okay, so today I'll be introducing you to the concept of detailing with templates, and we'll be starting off with the Stonebridge detailing template. If you are talking about templates, we are referring to industry design standard, right? That you can actually use to work on your personal projects. So templates are just predefined card files that helps you to narrow down your time and narrow down your effort, and helps you to meet up with the current industry standard when it comes to detailing. Okay, so today we'll be looking at column detailing with the Stonebridge structural template. So this template is a very important tool. It has different parameters, okay, and the important thing about it is gives you predefined or pre-designed structures, samples of predefined structures, so you can use from those samples in order to achieve your own structural detailing. So it has for design with pile foundation, which we can see here. It also have for design with pad foundation in this case. It also has for raft. It has for structural steel. So is a very important tool, and I will highly recommend for your structural detailing. Okay, so let's move over to the business of the day. So if you're familiar with our channel, you should be able to know this card file. Okay, so this card file was achieved in our first series talking about column detailing. So we already have an existing video on column detailing on our YouTube channel, so I will advise you go back to that video if you intend to get the basics of the basics when you are detailing your column. So today we'll be running over those basics, but if you intend to get the list of the list, I'll advise you go to that video. Is about an hour 20 minutes thereabout. Okay, so you can fully understand what goes on when we are detailing our column. Okay, so today we'll actually run over those basics in few minutes before we head on to detailing with our Stonebridge structural template, because the most important thing when you are talking about column detailing is ensuring you are passing information to the artisans on site, so those columns can be implemented with or without you being present with them on site. Okay, it is very important that they are able to do the right thing while you are on site or while you are not on site. So this was a previous detailed column as earlier said, and we'll be running over these basics that is required to detail your columns. So to run over what we did, or the basics of column detailing, right? We were provided with some project information to detail our columns. And if I put this side by side, let's quickly run over this. So this is just a sample of a typical two-story residential structure, and we were provided with these informations to detail with, right? So on the first floor here, on the ground floor here, we were provided with, for the column type 1 that has 6 numbers, we are provided a column size of 230 by 300 millimeter, and the column having 6 numbers of y16, and the length is y8 running at 175 millimeter spacing. Okay, so this was typical both for the ground floor, the first and the second floor. So it means we had the same column from here at this point and also at this point. So this was typical for this column type 1 and column type 2. The difference between column type 1 and 2 was the dimension of the column was 230 by 300 here, while in this part we had 230 by 230. Okay, but they all started off at the ground floor and continued from the ground floor to the first and also to the second floor. Okay, then we had different column type that we were given. The third column type, which is the type 3, it had a column size of 230 by 230, but the difference is against 4y16 which we had here, we had 4y20, and this only stopped at the first floor level. Okay, which is a sample of this column here that we have over here, starting off here and ending just at the first floor level. And the last column type we had on this structure was the column type 4, having 4y16, okay, and having a column size of 230 by 230, while it starts off at the first floor level. So this indicates we do not have this column starting off at this ground floor level, while this indicates we have this terminating here, so it is not continuous on these other 2 stories. Okay, so that is the first project information we were given, and the second project information were the parameters that guide your column detailing or your concrete properties. So if I also put this side by side, if I put this here, if I put this here and I take this to this column, okay, so the detailing information we had on the first floor beams, talking about the first floor beams, as you can see here, we had a thickness of 500 millimeter because this part is the ground floor, right? This part of the column is the first floor, while this part is what, the second floor. Okay, so or let's start off from the roof beams. So from the roof beams over here, we had 300 millimeter thickness, while for the second floor beams we have 450 millimeter and 150 millimeter for the slab. So if we come to our second floor, we had 450 millimeter thickness for the beams and we had 150 millimeter thickness for the slab. Then moving on to the first floor, we had 500 millimeter thick beam, while we had 150 millimeter thick slab as well. Okay, so coming down to this part, we also had 500 millimeter on 150 millimeter. So this is just to introduce you to the concept of this detailing, and these are the information, so these are the properties that will take on to your structural detailing with the template, because realistically when you are trying to detail your columns, these are the information that you will require. Okay, this is what you get from your design software in order to replicate them in a real life scenario. So the next information that we made use of was our concrete cover, our foundation depth, and the foundation type. So as you can see over here, the foundation type is a pad foundation having 300 millimeter thickness. The depth of our foundation was 1.5, and our concrete cover for our, let's dimension this concrete cover, which is the space you leave before your links. As you can see over here, we had 30 millimeter. Okay, so these were the project information we used to detail this column. So let's quickly run through the details column, and I will put this on a single view. So let's just take a few seconds to understand what is really going on with this column. Now, just to keep us in check, when we speak about column detailing, we are only trying to represent the reinforcement that will be used in the construction of these columns by lines and call out. Okay, so that is what we aim to achieve when we speak about column detailing. And if you are producing your column detailing, there are always two drawings. The first is your column elevation plan, which is this. It shows the elevations of their column with the reinforcements and their positions, right? While the second drawing that will come with your columns is your column section drawing. Okay, so these two drawings are vital for you to have an effective detailed column. So to run over the concept of this column detailing, as you can see over here, we introduced the different levels, which was the foundation level having a depth of 1.5, and we also introduced the ground floor level, the first and the second, making due regards to the difference in this story height. So as you can see, the ground floor was the final level of the ground floor was at plus 450, while the first floor was 3.6. So we also represented that on this column elevation drawing. So we have the ground floor to be, or let's put this side by side. So we had the ground floor to be at 0.450. The first floor is 3.6, is at 3.6. The second floor 6.75, and the last, which is the roof level, was 9.75. So by deducting these differences, we arrived at the story height of 3.15 meters for the ground floor. The first floor was also 3.15 meters, while the second floor was 3 meters. And our foundation, as earlier given in our project information over here, as you can see, it was given as 1.5 meters. And like I said earlier on, the concept of column detailing, or what you intend to achieve when you want to detail your column, is representing the reinforcements that will be required to construct these columns on site, representing them with lines and callouts. And these lines must be as neat, these callouts must be as concise as possible, so the artisans on site can do what they intend to do without even needing your presence. So what you understand with me is that any column that starts off at your ground floor must always have a link to your foundation level. It will always start at your foundation level as a starter bar. And let's quickly introduce that concept. Okay, we'll require that to detail the next column as well. So it means whenever you have a column starting off at your ground floor, you wouldn't just start them on this level. Okay, there has to be one part, or there has to be another reinforcement that goes into the foundation. Okay, this reinforcement goes into the foundation, comes out and lap with the columns on the ground floor. So these reinforcements are known as your starter bars. Okay, they start these columns, they are known as your starter bars. You can also have, you should also have starter bars for other structural members like your staircases and other structural members. But this is your column starter bars, and it will lap with the reinforcement on the ground floor, and it will lap with your column at the ground floor by a specific length. Okay, and the length of this lap that is required to provide proper anchorage for the reinforcement coming from the foundation level to the ground floor is gotten by multiplying 50 by the diameter of that reinforcement. Okay, so as you can see over here, we drew the first reinforcement, which is the starter bars, having a development length as regards to the standard. Okay, so we drew this to the foundation, to the top of the foundation level, and at the foundation level there is a crank that goes up to this point to lap with the reinforcement of the ground floor. Okay, and if you multiply 50 by the diameter of this reinforcement, which is y16, as you can see, if you multiply 50 by the diameter, we should have 800 millimeter. Okay, so this is the first concept. So this is how we are able to come out with this lap length. Okay, so to run over the reinforcement, we'll have a starter bars starting at the foundation level. Then we can now have our ground floor reinforcement. Then we can now have the first floor reinforcement and what the second floor reinforcements. So these reinforcements are represented by what, this red line. And the second form of reinforcement that is existing on this structure is our links. Okay, So let me take this here. Let me take this here, and let me take this to the section. Let me take this this is the column elevation plan, and this is the section drawing. Okay, so the first reinforcement is this main bar, as you can see over here. So from the project information, we have 6 numbers of y16. So we have it called out here. As you can see, this is the call out for the reinforcement. So we have it as 6 numbers of y16. And also, if you look at this column plan, if you look at this section drawing here, you can see we have 6 numbers of this reinforcement. This is 1, 2, 3, 4, 5, and 6. Okay, we have 6 numbers of this reinforcement, and their bar mark is 0, 1. Okay, their bar mark is 0, 1. So bar mark is another important concept that we'll also get to introduce before we head on to the final detailing. So the second form of reinforcement, and we'll come back to that, but the second form of reinforcement that we have on this drawing is our links. Our links, or our shear reinforcement, or our stirrups. It all depends on what you intend to call it. So the links is this reinforcement that is holding what our main reinforcement, that is keeping them in shape, right? And from our project information, our links was given as y8. It was given as y8 running at 100, and it was given at y8 running at 175 millimeter. Okay, so with this spacing, right, we are able to calculate the amount of links that is required to hold this reinforcement at this very foundation level. So as you can see, the depth here is 1.2. If you take out the part thickness from 1.5 meter, so in order to get the total numbers, we divided this 1.2 by this spacing. Okay, and we got 7 numbers. So we now have 7 numbers of this reinforcement, which is y8, and the bar mark is 0, 2, running at 175 millimeter. All right, so now that we've introduced the two reinforcements, let's come and have a little look at this bar mark. So we said the bar mark is very important in your column detailing because this is what gives an identity to every reinforcement on your detailing. All right, and we said there are some basic rules that guide this bar mark. Okay, we said if we have a reinforcement of this length, and we have this same reinforcement, or we have a different reinforcement having this same length. Okay, but the diameter of this reinforcement is 16 millimeter, while the diameter of this reinforcement is 20 millimeter. So it means this reinforcement, and the first reinforcement and this other one, they will all have different bar mark, because the artisans looking at these two lines, they won't be able to differentiate which is y20, they won't be able to differentiate which is y16. So each of these reinforcement needs to have a different bar mark, and somewhere they can trace those bar mark to. All right, so that's the only way they can know that this is y16 and this reinforcement is what, y20. So let's say we have this bar mark as 0, 2, so this can be 0, 3. So this is not the only condition that differentiates your bar mark. We also said that if we have the same reinforcement, in this case, let's erase this. So in the first scenario, we had the reinforcement having different diameters, right? So in this case, the reinforcement can have, if they have different lengths, right? Let's say we have this to be 1.5 meters and we have this to be 2 meters. Okay, in order not to confuse our artisans on site, this reinforcement also have to, these two reinforcement, we need to have different bar marks. All right, so when we get to when the artisans get to see them, they can know that the 0, 1 is 1.5 meters, and when they are cutting your reinforcement in site, they know that all reinforcement having bar mark 0, 1 is 1.5 meters, while all reinforcement having bar mark 0, 2 might be 3 meters or it might be 2.5. Okay, but so long as there is a difference in their length, the bar mark has to change. And the last scenario that we'll be talking about, the differentiating of bar marks, is you can have, let's erase this, you can have a reinforcement like this. Okay, and you can also have a different reinforcement like this. So the total length of this reinforcement is 1.5 meters. Let's say here is 500, right? This part is 500 as well, and this other part is 500. So the total length is 1.5 meter, and it is the diameter is 16 millimeter. While this other reinforcement is a straight bar, but the diameter is also 16 millimeter. So not just the fact that they have the same length and they have the same diameter, we also have to give them the same bar mark, right? They will need to have different bar marks because their bent of properties are different. Okay, so with this introduction, you can see the reason why over here over here we have this main reinforcement having a bar mark of 01, while the links, the 6 numbers or the 7 numbers of links that are required to hold this main reinforcement at this point are having bar mark 02, because not just are they separated by the diameter of the reinforcement, they are also separated by the bent up properties. Okay, this will be bent in this way, will be bent like this, while this will be we have a development length, it will come up to the foundation level, and we have a crank length to receive the reinforcement at the ground floor level. Okay, so this is for the foundation level. Then moving on to the first floor level, as you can see we have our main reinforcement here, but the bar mark here changes to 03. All right, we still have the same 6 numbers of this reinforcement on this level. We still have y16, but this main reinforcement has changed from 01 to 03. And why this has changed from 01 to 03 is because this the total length of this reinforcement, if you look at the total length of the reinforcement on your ground floor level, we'll have 3.15 coupled with our lap length, which is 800 millimeter. So we have a total of about 3.95, right? While the reinforcement at the ground floor level, it has a different properties. The total height here is 1.5 plus 800 millimeter and the development length, so this cannot equate to 3.9 meters. But moving on from the ground floor to the first floor, as you can see over here, we have the same reinforcement bar mark. So here we have 6y1603, same as what we have on this place, in this place, which is 6y1603. And the reason is that we have this same story height, which is 3.15, and we have the same lap length. So this reinforcement and this reinforcement are all the same, right? Then moving on from this place, we also have a different bar mark here, mainly because this reinforcement is having this story is having 3 meters height against 3.15, and the bent of properties here are different. In this case we have a bent of bar, while in this case we have what, a crank here. Okay, we do not have this up to 800 millimeter. All right, so this is what we did in the previous times, and if you intend to get a full understanding of the basics of column structural detailing, there is a link in the description for you to head on to that video. So just to quickly actualize what we have discussed so far, okay, let's head on to quickly detail this second column here. So let's just create a copy of this first column just to establish more what we have just discussed. If we create a copy of this column from here to this point, okay, let's come here, and if we look at the second column type, we have this to be 230 by 230, while the reinforcement is 4y16 and our length is y8 at 175 millimeter. So this column comes from the ground floor to the first and to the second floor, so it means it's similar to something that we have over here, right? So if I have to detail this quickly, I will come here and I will draw a column size of, let me draw a column size of 230 by 230. Sorry, I'll draw a column size of 230. Let's say 230 by 230. Okay, so just after this we'll head on to the template. the good thing about the template is you don't need to draw any of this. You do not need to draw any of this from scratch. Okay, so this is our column, and from our project information, our concrete cover is 30 millimeter. So we'll offset 30 millimeters inward. Yeah, and we'll match the properties of this with this. Okay, so we'll copy this reinforcement from this place down to this place. All right, and we can mirror this. Okay, this is detailing the second column type, so we can mirror this as well. Okay, then we can have our column dimension. If we dimension this to be 230, okay, by 230, and let's quickly copy this. Let's copy this bend, copy from this edge down to this edge. Okay, let's also match these properties of this to what we have over here. All right, so if we are to detail this second column in this very template, this is what we should be trying to arrive at. Then if we need to call out this column, right, it means on this column elevation drawing, this will change to 4 numbers of what, y16. Okay, this will change to 4 numbers of y16, and the bar mark will still be 01. And the main reason why this will still be 01 is we have the same reinforcement diameter, and we have the same foundation depth, and we still have the same lap length, which is same as what we have on this previous drawing. Okay, but coming to the links, coming to this link, as you can see over here, we have the column size to be 300 by 230. While this one, we have it to be 230 by 230. So it means the links that will be required in this column is actually different from the links that will be required in this column. Right? They can have the same diameter, but their length will be actually be different. So in this case, we need to give this other link a different bar mark in order to differentiate it from what we had previously. Okay, and if you come over here, you will see that the highest bar mark we had in this part was 04. So when detailing this specific column, this will change from 02 to this will change from 02 to 05. Okay, so the iron benders on site or the artisans on site, they do not cut this link that is meant for a 230 by 300 column for this other link that is meant to hold a 230 by 230 column. So with this idea that we've established, let's go on to the Stonebridge detailing template, and let's detail the type 3 of the column. Okay, so just a brief information about this template. Again, it gives you samples of a complete working drawing that has been done, right? So this very sample is for a pad foundation. There is also a sample for a pie foundation. So it will give you a sample of how you should detail your pad bases. Okay, this is the pad general arrangement. These are the detailing of your pad bases. Okay, these are the detailing of the columns. This is the slab general arrangement. This is the slab detailing. So it is a very useful tool. Okay, but in this case, we are concerned about detailing our columns on a pad foundation. So I will just create a copy of this, and this is something you should do. So you can always have a copy of the original Stonebridge template. So I will create a copy of this from this point to this point, and let me modify this to suit the very detailing in question. All right, so permit me to tie these two drawings vertically. Okay, I will bring this here, and I will bring this to the right hand side. Okay, So keep in mind that we are detailing the type 3 of this column, and if you look at the properties, you can see that the type 3 of this column, it starts off at the ground floor, which means it will has a starter bars, and it stops just at the level of the first floor, and the column size is 230 by 230 millimeter. The reinforcement, the main reinforcement is 4 numbers of y20, and the links we have y8 running at 200 millimeter. Okay, previously it was y8 at 175 for both column type 1 and 2, but in this case we have what y8 running at 200 millimeter. Okay, so let's see how we can replicate this in a real life scenario making use of the Stonebridge detailing template. So if we come over here, let's edit this to suit our current job, and I will start with the foundation properties. I'll start with the foundation properties. Okay, so let me take it to any of the previously detailed column. So our foundation height is 1.5 meters, right? And our column, our part thickness is 300 millimeter. So this is the height before the finished floor level. So over here we have it at 1.65. Okay, so I will come here and I will edit this to 1500, right? And this place remains plus 450, this place remains 300. So if you subtract 450 and 300 plus 1.5, then we should be having, if we come to our quick calc, so if you take 1500, sorry, let me cancel this, 1500, and we'll subtract 450, and we'll subtract 300. Okay, so there we should be having here to be 750. So this changes to 750. Okay, so 750 plus 300, this should give us 1050 at this height. Okay, so we are done with the story height of the foundation level, and the story height of our ground floor level, we have it as 3.15, and coincidentally we also have that story height as 3.15 on the Stonebridge template. Okay, then looking at our concrete properties here, we have the depth of our beam to be 500 millimeter. Meanwhile we have it to be 450 millimeter at this point. Okay, so I know you might be wondering, why don't we try to draw this to scale. Do not forget that the most important thing in detailing is being able to pass an effective, or being able to communicate effectively to your artisans on site. There is never a time where the artisans or the iron benders will take out a tape or will take out a meter rule and try to measure your drawing to scale, right? What they will look at is your dimension. So what is important is you give them the appropriate information. Okay, you give them the appropriate information that is required. So this will be edited to 500 millimeter, and this will be at 150 millimeter. Okay, so we are done with the story height, and let's look at the reinforcement. Okay, so coming to the reinforcement, as you can see over here, we have here to be 4 numbers of T16. So let's come here, we have this to be 4 numbers of y20, while on the Stonebridge template we have this as 4T16. So we need to edit this to suit. Okay, so we'll edit this, right? We'll come here and we'll edit this to be 4 numbers of y20. That is for our main reinforcement, which is this reinforcement. So the Stonebridge template, due to their standard, they've been able to, provide something that even when we draw through reinforcement, the detailing does not look clumsy. It still looks as clear as possible. So that is why I said it's one of the most important or vital tools you can get in the market. Okay, So this is four numbers of y20 and our bar mark here. So we'll just have to continue with the bar mark we use on this very link. So we said this should be 05. So coming to the bar mark, the highest bar mark we had in this drawing was 05, right, which is the newly introduced links, which is was this newly introduced links. Okay, so it means we need to have a different bar mark for this reinforcement because the diameter has changed from y16 to y20. So since we have 05 here, it means this will be changed to, this will be changed to 06. Okay, so our starter bars is 06. All right, and let's move on to the links. The links, if we come back to our project information, let's come back to our project information. We have our links as y8 at 200 millimeter spacing. Okay, so all these other informations, like all these informations for the powered basis, the work compacted field, all this other information, we'll come back to it and edit them appropriately in order to suit this specific design. But firstly, like I said earlier, let's start with the reinforcement. Okay, so this is changing to y8. This is changing from t10 to y8. Okay, and the bar mark this will be 05 because this is a 230 by 230 column. That means the links which we got here, okay, which is y805, is still the same link that we will use for this other column. Okay, so this spacing changes from 175 millimeter and this goes to 200 millimeter, right? So we have this as 4y1206 starter bar and 6y805 200 millimeter spacing. So now let's get the total numbers of links that will be used to construct this part. So in order to do that, we'll get this depth, this foundation depth, which is 450 plus 750, which is actually 1.2 meters, by the number of spacing. So if we divide 1.2 by 200, so it means we have 6 numbers. Okay, so these 6 numbers of y8 is still valid at this very location. All right, so let's move on from the foundation level and we look at the reinforcement at the ground floor level. Or if we come back here and we'll try to calculate this number of links, you will see we have 1, 2, 3, 4, 5 and 6 numbers. So this is actually adequate. Okay, so let's move on to the ground floor level. So on the ground floor level, our story height is 3.15 and our shear reinforcement, we have it as y8 running at 200 millimeter spacing as well. So if we edit this, to y8, and this will still maintain bar mark 05. Okay, but it's now running at 200 millimeter spacing. But if we intend to get the total numbers of reinforcement, it means we have to divide 3.15. You have to divide 3.3150 by 200. Okay, so in this case we are having 16 numbers of reinforcement. So it means this will change from 21 numbers to 16 numbers. All right, so like I said in our previous video, what you should understand is if you intend to get the adequate numbers of shear reinforcement required for this story, then you have to take your dimension from this point to this point and not the total story height. So it means you have to subtract this 500 millimeter from 3.15 meters. And why you are doing so is this point where we have 500 millimeter or where we have our beams, this shear reinforcement will not be present there. Okay, so this links will not be required at this point. So it will only be required just below where we have the beams. So in order to get the adequate length, you have to subtract this 500 plus from this 3.15. But in case you are trying to be conservative, then I will advise you go with the total height of the story. Okay, So we have 16 numbers here, and let's come here to edit the total numbers of these links. If we equally count this, you can see we have about 1 2 3 4 5 6 7. Okay, so we have 17 numbers of this. Okay, we have 17 numbers of this present. Okay, so what I'll do is I will just erase this. Okay, just to give a concise understanding. And our lap length, since we are dealing with y20, it will change from 800 millimeter to 50 multiplied by, let's say 50 multiplied by the diameter, which is 20. So in this case we have what, 1000 millimeter. We have here to be 1000 millimeter lap, okay, with a 75 millimeter kicker. And you should know what kicker is. The kicker is our concrete which we construct on site. You know, there is always a small concrete here in order to create the boundaries for your columns, okay, to create the boundary for your the concrete part. Okay, so 75 millimeter kicker. So the Stonebridge template provides you with all this information. Okay, so now we successfully edited this, and this will also change from 4 numbers of T16 to 4 numbers of Y20. Okay, and the bar mark is, it doesn't have the same length with our starter bars. So the maximum we have here is 0.6. So this will change from 0.6. Okay, so this will change to 0.7. Okay, so we have 0.7 at this very level. All right, so the next thing will be coming down to edit these properties. This changes from 225 to 230 to suit our currently detailed column. Let's take this back here. Okay, and this changes from 225 as well to 230. Okay, then this section, as you can see here, we have here to be, we now have here to be y8. We have here to be y8, bar mark 0.5, running at 200 millimeter spacing. So we can decide to include the numbers, which is 16 numbers. So we can include 16 y8. Okay, 200. So let's drag this further a bit, and this is okay. So you can see in less than no time, without much stress, we are able to edit this column in order to suit industry standard. So now let's come over here to other parameters that has been provided by our Stonebridge detailing template. So let's head on to other parameters that has been provided by the Stonebridge template. So the first parameter is, if we look over here, we have our foundation details called out. Okay, so from experience, and I will strongly advise you do not detail your pad foundation coupled with your column. Okay, you always have a different drawings for your pad foundation and always have a different drawing for your columns. And why that is important is, if you look at this layout drawing, which has been the sample that was provided by Stonebridge, you will see that we have here to be column 1, we have here to be column type 1, we also have this to be column type 1, right? But the foundation details, we have here to be footing type 2, we have here to be footing type 3, and we have here to be footing type 4, right? So it will be difficult to represent all these footing type on just one column. So what I will advise you do is, when you come here, okay, firstly, for the size of the footing, what you should put here is varies. Okay, it should indicate that this varies. So it means this column type 1 can be sitting on pad base type 1, it can be sitting on pad base or footing type 2 or footing type 5, but it is the same column type 1. And I hope I am not confusing you at this point, right? So what I mean is, your column type 1 can be sitting on different pad bases. So I'd advise you put this dimension as varies. Why at this point I will take out this detailing, and let me drag this to this point as well. Let me drag this here. Okay, then I can say, I can come here and say see pad detail sheets. Okay, pad details, or see foundation detail drawing. Okay, see foundation detail drawing. Or let me, to make more reference, to add more reference to this, I can say uh refer, let's say refer to sheet sheet let's come here and look at this sheet number. So refer to sheet 02. Okay, so when they come to 02, they can see the different detailing of the part bases. Okay, what you just have to do here is give them an idea of what to expect and how to place this reinforcement. So you can now say refer to sheet 02, right? I strongly recommend you use this alternative than detailing your different columns on different part basis. So in that case, you'll be having like, for only column type 1, we'll be having like 3 different drawings, because we have to represent 1 4 by 1 4 part base. We also have to represent 1 5 by 1 5 part base, then 1 6 by 1 6 part base. Okay, so let's edit further. This has already been done. This is well compacted backfill. We will leave this as it is, because this is the proper way you intend to construct your structure. Then this as well compacted backfill on both sides. And for the template provided by the Stonebridge company, this part here, it has a mini step. From my observation here, it has a concrete stair, 300 millimeter stair thread, and 150 meter. So we don't really need this, so we can erase this, right? And we can erase the stair as well. Let's erase everything related to the stairs. Okay, so what we can do is we can bring out these properties, which is 125 millimeter mass concrete, 50 millimeter thick blinding, waterproof membrane or your damp-proof membrane, and well compacted backfill. Okay, this is a call out of what you are expected to do on site. So if on your site the mass concrete or your foundation slab is 150 millimeter, so you can come here and edit this to 150 millimeter to suit. If your blinding is 75 millimeter, you can come here and edit this to 75 millimeter thick blinding. If your waterproof membrane, if you have other membrane or you have other levels before this membrane, you can come to add this to your details. Okay, so what I will just do is I will select this that represents this concrete slab, the thickness of the blinding and the waterproof membrane, which is this. This is the blinding, this is the membrane, this is the slab. So I will copy this, and I'll select this, and I'll mirror from the midpoint between this point and this point. So I'll mirror this to the right hand side. Okay, and I'll erase this. So as you can see, in less than no time, we've been able to provide proper detailed information for this column type 3. And if we go ahead to print, the good thing about this drawing, if you go ahead to print this, let's just take a view. If we go ahead to print this, and if you preview, right, if you preview, you can see how neat, right, you can see how neat and detailed this drawing is. So this is a very important tool that can help you to detail any type of foundation. It's a complete template that has for pad foundation, it has for detailing with pile foundation, it has for detailing with raft foundation, it has for detailing with strip foundation. So this, when I came across this, I was glad. So it's a very important tool and I will highly recommend this. So to get this, there is a link in the description to our online store, and you can uh, get it from over there. Okay. So yeah, this is how you can edit your column to suit the requirements of your specific structure using the Stonebridge detailing template. So if you come across other useful template as well, we actually make out tutorials on them and how to use it.